Hi everyone, thanks for joining. In this video, I'm going to walk you through a Kubernetes native way to deploy legacy JBoss EAP 7.x applications on OpenShift. This video is aimed at customers who are still running JBoss EAP 7.x, which is now under extended lifecycle support, and who cannot modify their application code. The goal here is not to rewrite applications, but to change how they are deployed and operated. Let's start with the reality many customers are dealing with today. JBoss EAP 7.x is still running mission critical workloads. In many environments, the application code is frozen, the original development team is no longer available, and all that exists is a pre-built WAR file. At the same time, platform teams are being asked to move these workloads to OpenShift as part of their modernization or upgrade journey towards JBoss EAP 8. That war only constraint is what drives the entire design you will see in this demo. So, what does this demo actually solve? It shows how to deploy a war only JBoss EAP application on OpenShift without any application code changes. It also shows how database configuration can be fully externalized and customers can completely customize the database vendor, driver, or version for their application. As a bonus, this demo will show that by careful architecting, customers can change their database vendor by configuration changes alone at runtime. And most importantly, provides a low risk incremental path forward towards JBoss EAP 8. Let's quickly align on the architecture before we dive into code or terminals. Everything I'm about to show you directly corresponds to this diagram. Excuse me. So keep it in mind and I will refer to it as we proceed. The process leverages a binary build to inject the pre-created WAR file, meaning no actual source code compilation occurs. Essentially, this binary build consumes artifacts like the WAR file, custom configurations, and necessary database drivers to construct a customized JBoss EAP container on OpenShift. It's important to note that JBoss drivers, JDBC drivers are installed as server modules and not bundled within the application itself. And the data source is configured using environment variables. Now that we understand the architecture, let's see how this is implemented in code. Before we go any further, I want to spend a couple of minutes orienting ourselves in the GitHub repository. This is important because the structure of this repo directly reflects how the OpenShift source to image or S2I build process works. I am not going to explain every file in detail. Instead, I will highlight the major pieces and their roles. At the root of the repository, you will notice things are intentionally lightweight. There is no complex application build logic here because the application is already packaged as a war. The real focus is on how the war is deployed and operated. Looking at the binary input, this directory is the heart of this demo. Everything inside the directory is what OpenShift consumes during the S2I build. You can think of it as the payload we hand over to the JBoss EAP OpenShift image. Looking at binary input deployments folder, under deployment you will see the application war file. This war is already built outside OpenShift. That's deliberate. OpenShift is not compiling the application code here. It's assembling a runtime image around a pre-built artifact. This is what makes the approach suitable for legacy, war-only type of applications. Looking at binary input extensions. The extensions directory is a key S2I concept. Anything placed here is treated as an extension to the base JBoss EAP image. This is how we will customize the server without modifying or rebuilding the base image itself. Looking at install.sh file. The install.sh script runs during the S2I build phase. This is where we perform build time customization of the server. In this demo, we use it to install JDBC driver modules and register those drivers. In other words, things that belong to the server image, like drivers, are handled here. Let's look at the modules. Under modules, you will see the Postgre and MySQL JDBC drivers. These are installed as JBoss modules and not bundled inside the application. This follows a best practice where that drivers are a platform concern and not an application concern. Looking at drivers.env file, excuse me, is used by JBoss EAP S2I image to declaratively register JDBC drivers. This allows us to add drivers without writing custom registration scripts. Again, this is leveraging supported S2I behavior. Now, you will notice that there are two branches in this repository. One branch demonstrates a full configuration copy for heavily customized environments. In this case, this is the branch. Let me switch to it, right? And then the other uses post configure switch, which was the earlier one, for a more Kubernetes native approach. And this is intentional. Both patterns exist in real environments. Now, the main branch here in this case, or the full configuration branch, this is meant for customers with heavily customized EAP environments. If you already trust your existing EAP configuration and just want to containerize it, this approach minimizes change. As you can see, I have a full EAP configuration here. I have customized it to configure the log level of my application package to debug. That is my trivial customization for the purposes of this demonstration. Switching to the post configure branch, this branch is for customers who want smaller incremental customizations. Here we only apply the delta using CLI scripts and runtime. Both approaches are supported. The right choice depends on where the customer is today. Let's look at the post configure script. Now, post configure.sh runs at container startup time, not during the build. This is where we apply targeted configuration changes using the JBoss CLI. Because it runs after the server starts, it can safely connect to the management controller. This makes it ideal for small incremental configuration changes. The configuration delta. This CLI file contains only the configuration delta. In this demo, we use it to enable debug logging for the application package. The important point is we are not replacing the entire server configuration. We are only applying what's necessary. So, at a high level, this repository shows how to use the JBoss EAP S2I process to assemble a runtime environment. The application remains untouched. The server concerns like drivers and configurations are handled externally. That separation of concerns is what makes this approach scalable and maintainable. Now that we understand the structure, let's see how this comes together. A key principle for this demonstration is var-only deployment. So, as we have already said, OpenShift is not building the application. The var file already exists and we supply it as an input to the OpenShift binary S2I build process. OpenShift becomes the runtime and operational platform, not the application build system. Let's see that in action. We first create a build using the JBoss EAP base builder image and mark it as a binary build. And then Set some build environment variables to ensure the S2I process picks relevant files from correct directories. And then we kick off the build. What's happening here is important. OpenShift is assembling a runtime image. It's injecting the war, installing driver, and preparing the server. There is no Maven build and no application sources involved. Let us wait for the build to finish. Okay, the build is complete. Let us proceed. Now let's talk about databases. The application does not contain any JDBC driver or database URL. It uses and looks up a JNDI data source and that is injected into the application via environment variables. JDBC drivers are installed as JBoss modules, which makes them a platform concern. Let's look at how that's implemented. Here are my MySQL modules. Notice that they are not inside the war, and the driver registration happens through supported S2I mechanism. This keeps the application portable. One of the most powerful outcomes of this design is that we can switch databases without rebuilding the application. Let me prove that. I'm going to switch from using PostgreSQL to MySQL database at runtime with no application change. First, let us create a new JBoss EAP instance from the image we just created as a result of the S2I binary build. Then we expose the service. And now we inject environment variables into our application deployment that will connect our application to the PostgreSQL data source that was configured at runtime. Let us check whether our rollout was successful. It is. Now let us, in case you are wondering, I have kept a PostgreSQL and MySQL database instance already running on my OCP cluster. Let's go and check that out. Here you go, MySQL, PostgreSQL, and this is the deployment that I just uh, deployed. Now let us take the URL. Let me copy this and let us test the application. And there you go, our application running fine. Let's go and check the database. Here the code is written in such a way, every time I invoke the DB endpoint, it makes an insert into this table called demo ping. Now let me show you that it is indeed taking from the Postgre database. I'm going to show you this value in the database itself. For that, let me go inside the Postgre container or pod. Go to terminal and the table name, the entry that was made is demo ping, and we have 6. This is exactly. If I simply go ahead and refresh couple of times, it's going to increase. And let's go back and check it out. Here you go. Now let us switch to using MySQL. And for that, all I have to do is I have to set the environment variable so that my deployment chooses the appropriate database. So let's go ahead and do that. All right. And this is the application window. So remember this is PostgreSQL 8. Let's just refresh it. This is 13. This is MySQL. Let's do it a couple of more times. 14. Let's go and check this value in MySQL. MySQL should be 12. So right now this was PostgreSQL pod. Let's go back to the pods. MySQL pod terminal, and let's again do a count. Here we go. 14. This is what we saw. 14. All right. So after that, let's move on with configuration. Now, configuration is where customers usually differ the most. That's why this demo intentionally shows two approaches. If your existing EAP configuration is large and complex, the full configuration copy approach works well. If your customization needs are small and controlled, post-configure scripts are cleaner and more maintainable. Both approaches are valid. The key is choosing intentionally. So, the big question on everyone's mind is which of these two configuration approaches is right for you? Really, it comes down to where you are today. It's if you are one of those customers with a massive, heavily customized JBoss EAP environment, I'm talking about tons of data sources, custom security realms, and a lot of JMS tweaks, then the full configuration copy is probably your best bet. It's the faster way to get containerized because you are essentially just lifting your existing trusted configuration and dropping it in. However, if your customization needs are smaller, more controlled, and your goal is to move toward a truly cloud native maintainable setup, especially as you prepare for the move to JBoss EAP 8, then the post configure scripts approach is cleaner. It's the Kubernetes native way where you only apply small targeted changes using the JBoss CLI scripts at runtime. The choice is yours, but it's important to select the path that aligns with your team's expertise and your ultimate modernization goal. Let's see configuration customization in action. So right now the configuration has a debug log enabled for the application class example.com. Let us first modify this using the full configuration copy method. We will change the full configuration and remove the debug log and rebuild the image and redeploy the EAP image using the process that we used earlier. Let us first confirm that our debug logs are coming. As you can see, this is the logs that is coming. This is coming from com.example db servlet, which is our application package. All right. Now we are going to turn this off using full configuration mode. What we are going to do is we are going to take the standard OpenShift configuration, which is this is the full configuration, and we're going to remove this out, save it, and then we are going to initiate the build. Okay. We're going to start the build again. This time it's going to build with this changed configuration, but it is going to copy the full configuration. So let us wait for the build to complete and then it will proceed. Let us now go ahead and invoke the endpoint. Here you go. Let's just do it couple of times. Okay. And now let's go and look at the logs. Here you go. The logs are no longer there. Okay. So that demonstrates how you can use a complete configuration to customize your JBoss API. Now let's try the other way around also. We are going to bring the debug logs back using a post configure script approach. All right. So let's see how that happens. All right. Now, since we have gone to this branch, and in this branch we don't have to do anything because the changes are already there, which are this post configure.sh and this CLI file. Okay. So once we do the build and the code is built, we are going to verify whether this post configure.sh script got runs after the server startup happens. So we are going to verify that, and also we are going to verify whether the debug log comes back or not. So let's wait till the build completes. Here you go. We have post configure.sh applying CLI config that is coming from our post configure file. Okay. Now, just to ensure that we are getting the debug logs, we are going to we're going to follow the logs for a moment. While this happens, we are going to go into our browser and refresh it. This is going to force that log again. So let's wait a couple of times, twice. And here we go. Voila, they are back again. So by default, this obviously this is not there. So we did not upload the full configuration this time. We only uploaded a portion of enabling the debug log for the com.example package, and that also was invoked once the server started and not during the build. Okay, moving on. So this brings us to the future. How does this all help us prepare for JBoss EAP 8? The key is a low risk incremental approach. The first step is to get those legacy EAP 7.x workloads onto OpenShift, just as we've demonstrated. By doing this, you instantly start to decouple the platform from your application code. This separation of concerns significantly reduces your overall migration risk. You're no longer attempting a massive big bang rewrite of your application and a platform move to at the same time. You handle the deployment and operation modernization first. Once that's stable, the application level upgrade to JBoss EAP 8 becomes a much simpler contained project. And that brings us to the final and most important takeaway. The core message here is that modernization is a journey, not a big bang event. You don't have to rewrite everything to move forward. By leveraging the power of containers and OpenShift, you gain the ability to decouple your platform from your application code. This gives you the leverage you need to start small with deployment and operations, and trust me, when you get that part stable, the rest, like the eventual move to JBoss API 8, becomes significantly easier. Thanks for watching.